Welcome to GATE CSE. In this video, we will discuss about the invertible, also called as non-singular matrices, and also we will find a method to find the inverse of a given matrix. So let's begin. What is this invertible matrix? Matrix is said to be invertible or non-singular. That means if the matrix inverse exists or not. So the condition is, suppose say there is a matrix A and there is a matrix B. Product of these two, A, B and BA should be equal to I. Okay, so that means what? If I take this, B is equal to, it becomes A inverse I. You write the inverse like this, A inverse I. This product of any matrix with identity matrix is same matrix I get. Similarly, if I take A is equal to B inverse I, that is equal to B inverse. So that means what? Both the conditions should hold. If AB is equal to I and BA is equal to I, then only the inverse exists. Okay, then only the inverse. This is not OR, both should hold. Okay, so be careful when you check for the non-singular matrix, both these conditions should hold. Why? We will see the property now. See, this is called as the uniqueness of inverse. It means for any given matrix, there is only one inverse that exists, unique matrix, that is inverse of that. There cannot be more than one inverse of a given matrix. So let us say there is a matrix A and B1, let us say it is the inverse, then this condition should hold. Okay, and there is one more matrix, okay, same matrix A and one more, let us say B2 is another matrix, and to find this inverse, this condition should hold. That means what? Uniqueness means if I find this B1 or B2, always B1 is equal to B2, both matrix will be same. That means what? The inverse of A, if exists, will be equal. I mean, it is same. So there is only one unique, one B1, B2, both will be equal means there is only one unique inverse of that matrix A. So let us see how to verify this. What is the condition? So they are given two matrices. So they want to check whether A and B are inverses of each other. Okay, they are saying that given A is the B inverse of it, or given B is A inverse of it. What is the condition? AB should be equal to I, that should be equal to B into A. So now we find the product of the matrix AB. So this will be 6 into 1 plus 25. Okay. Then the second column, the first row, 6 to 0 minus 30. And now you need not proceed because see, this element becomes 31. This becomes minus 30. Okay. That means what? Sorry, plus 30. That means what? See, it is not identity matrix. See, I should get identity matrix if I multiply both. So to do both, but here it is not identity matrix that I am getting. So from here only you can stop and say inverse does not exist. It is not A and B. A is not the inverse of B, or B is not the inverse of A. So you can check. The only thing is after I take the product, you should get identity matrix. The identity matrix will be like for this 1 0 0 1. So for both AB as well as BA should be I. But here we are not getting that. We are getting 31, 30, something like this. So it's not an identity matrix. Okay. Then the property of product of inverses. Let us say I want to find AB inverse, product of two matrices AB and the inverse of the resultant matrix. So this will be always equal to B inverse comes first into A inverse. If I have say K matrices, A1, A2, product of all these, say K or N matrices, then if I take the inverse, it will be in the reverse order, that is AK inverse first, then into A K minus 1 inverse, so on up to A1 inverse. So this is the property of product of inverses. Next, We'll find the steps to find the inverse of a 2 cross 2 matrix. So for a 2 cross 2 matrix, it is very simple. For 3 cross 3 matrix, we will see the method. There are two methods in general. So one method we will understand in this video. Next method I will explain in the third chapter. Now, how to find the inverse of a 2 cross 2 matrix? It is straightforward. First, interchange the diagonal elements A and D. Okay, so diagonal elements means I am talking of main diagonal or principal diagonal element. Then change the signs of the off diagonal elements. Off diagonal means other than the diagonal, one more diagonal will be there, right? In a matrix there will be two diagonals. One is principal or main diagonal and another is off diagonal. We call it as off diagonal, other one. Okay. So now one more thing is a matrix is invertible if and only if determinant is not equal to 0. We'll see why later. Now, so how to find? So what they are saying first, find the determinant. Determinant of this matrix is given by this AD minus BC. Then if determinant is not equal to 0, then A inverse equal to 1 by the determinant of A into, so first what to do, this is the principal diagonal element. So interchange the element, that means instead of A, it will be D. Instead of D here, it will be A. Okay, interchange them. They have interchanged here. Then change the signs of these two other two elements. Minus, it is what was plus, make it minus. If it was minus, then make it plus. So change the sign. Then we will get the A inverse like this. 1 by determinant of A into this changed matrix, what you got. Okay, why determinant should not be equal to 0? Because if I get 0 here, this is A inverse equal to 1 by determinant of A into this matrix, right? So if it is 0, then I cannot find the inverse. That's the reason why determinant of A is not equal to 0. So let us find the inverse of the following matrix. So first, let us find the determinant of it and check whether it's non-zero. So it will be 10 minus 12 is minus 2. Now, so inverse of A exists and it will be equal to 1 by minus 2 into, so change these two elements, interchange these two elements, becomes 5 and then 2. Then change the sign of these two elements, that is minus 3, minus 4. So this is my A inverse. Next. Now, we want to find a matrix inverse for n cross 1 matrix, that is other than 2 cross 2, 3 cross 3, 4 cross 4, how to find. So for that, first you have to find the adjoint of the matrix. What is this adjoint of a matrix means? Adjoint means you first find cofactor of every element in the given matrix A. Okay. And then you take the transpose of that matrix. Then we'll get the adjoint of that matrix. Okay. First find the cofactor. So how will you find cofactor? Cofactor, the set cofactor of say first element A of ij, if any element ij is equal to minus 1 to the power I plus j, okay, into the product of that n cross n minus 1 cross n minus 1 matrix, right? So you already know how to find this. So let us see with an example, you'll understand. So how to find the adjoint of a matrix? So first find the cofactor of cofactor matrix. How will you find cofactor matrix? So for 1, what is the cofactor of 1? So 1 means cofactor of 1, first element, is equal to minus 1 to the power, this is 1, 2, 3, row, column is 1, 2, 3. So I plus j, 1 plus 1 into this n minus 1, that is 2 cross 2 matrix. So what is this becomes 0 minus 24. So this will be equal to minus 24. Okay. Then similarly you find cofactor of the second element, this 2. This will be equal to minus 1 to the power. So this is first row, second column. So 1 plus 2 into, so now I am considering this element. So ignore this row and this column. This will be 0 minus 0 and minus 20. This will be equal to 20. So this is how you find the cofactor. So cofactor, right? Rest of the elements you can find it like this. I will give answer here. So cofactor of matrix A is cofactor matrix we call. So this will be minus 24, 20, minus 5, 18, minus 15, 4, 5, minus 4, 1. How will you find the adjoint? Adjoint of A is equal to transpose of this cofactor matrix. Okay, cofactor matrix, cofactor of matrix A, take the transpose of it. That means interchange the rows and columns. That means adjoint of A is equal to, it will be minus 24, 20, sorry, minus 24, 20, minus 5. The row becomes columns in the transpose. Then 18, minus 15, 4. Then 5, minus 4, and then 1. Okay, minus 4. So this is how you find the adjoint of A. Next, for a square matrix A, so how will you find the inverse now? So inverse for a square matrix n cross n. So you can take the inverse only for square matrix. Okay. How will you take it? So A inverse, if it is a 2 cross 2 matrix, it is very easy to find. But here, for A inverse for 3 cross 3 or 4 cross 4 or any higher order, but to find determinant of the matrix is A inverse equal to 1 by A into adjoint of A, and determinant of A is not equal to 0. So this will give you the inverse of any matrix A. Okay. So let us take an example. So you already found cofactor. So A inverse is equal to 1 by determinant of A into adjoint of A. Now, what is determinant of A? Determinant of A is equal to, so to take one cofactor into 1 into cofactor of that, right? So cofactor will be, so minus 1 plus 1. Okay, so the 1 only positive. Then this is 0 minus 24 plus second element minus first 1 power minus 1 power 1 plus 2, that is 3. So minus 1 cube is minus 1. So it becomes 2, this element, into this row is ignored, this column is ignored, 0 minus 20. Okay. Then plus 3 into minus 5. So we check, we'll get determinant as minus 24 plus 40 minus 15 is 1. Determinant is 1. So already found out the adjoint. So to find the adjoint and then it as 1 by 1. So adjoint of A is given as minus 24, 18, 5, 20, minus 15, minus 4, minus 5, 4 and 1. This is how you find the inverse of the matrix. Okay, now we'll see some special square matrices. So there are many special matrices. Okay, we will learn more about them in 6th chapter, but in this chapter we'll learn about symmetric and symmetric matrices. Okay, this helps in solving many of the problems. The other special matrices are orthogonal matrix, normal matrices, okay, and then we have projection matrix, submatrix, and all those things. Once we understand some more concepts, we'll deal with them in the last chapter of the subject. Okay. Let us see what is symmetric and skew symmetric. Very simple concept. Square matrix A is symmetric if A transpose equal to A. If I take the transpose of matrix A, then A equal to A transpose. It means what? A of Ij will be equal to A of Ji. Okay, so it will have the image on the diagonal, other side of the diagonal. Similarly, skew symmetric will be A equal to minus A transpose, and one more condition, diagonal elements are 0. Principal diagonal elements are 0. Okay. that is A I equal to minus A I, the same element on the other side. Let us see an example. Determine which of the following matrices are symmetric, skew symmetric, or neither. Okay, so now what is symmetric condition? So this is the principal diagonal element. Either side of that should have the same element. That means this is A of ij, right? So it is A of 1, so 2, second row, first column, be equal to A of 1, 2, that is first row, second column. So this element and this element should be equal. This element should be same. This and this should be same. So it is a symmetric matrix. It holds the properties of symmetric matrix. Now, so is it symmetric matrix? Let us check. So this A of 2, 1 should be equal to A of 1, 2. But here they are not equal. It's minus 3, it's 3. So it's not symmetric. Is it skew symmetric? We'll check. First, the diagonal element should be 0. Yes, diagonal elements are 0. And it should be A of the number A of 1, 2, A of 2, 1 should be equal to minus of A of 1, 2. Right? So minus 3 plus 3. Okay, 4. So 4 minus 4. Minus 5 and 5. So this is a skew symmetric matrix. Then what about this? See, this is not a square matrix. The order is what? 2 cross 3. So it cannot be symmetric or skew symmetric. So for symmetric and skew symmetric, we have to have the square matrices. For inverse also should have square matrix. Okay. So for special matrices, whatever you learn in this linear algebra, all are on the square matrices only, n cross n. Not symmetric and not skew symmetric also. Okay. So in the next video, we solve any interesting questions, problems. Okay. Using this all the concepts you learn fundamentals of matrices. Okay. So let's continue in the next video. Please like, subscribe and share. Thank you.